Hello, my name is Mason Horder, and for my project, I chose to reverse engineer a light switch. I chose this as well as exploring options. I realized light switches are complicated devices. All of us use dozens of times per day, and we never stop to think about the complex engineering behind it. A light switch works by flipping the switch on and off. In the on position, it allows springy metals to connect to each other, thus allowing electricity to flow. In the off position, it pushes these connections apart. Wires are then screwed into the sheet metal conducting plates. A light switch actually contains many parts as it has been perfected over 50 years. Here we can see an animation in the top left showing how my model flips from on to off. In addition, the exploded view of the light switch shows all the components. The bottom left shows the head of the light switch, the actual switch itself, containing the prongs to push the metal in place. The bottom right is the upper case, which houses all of the components, including the conducting plates, the screws, the light switch, and connects to the final component, which is in the top right, the frame. This allows you to mount the switch in the wall and also establish a ground connection via the green screw. Here's the drawing for the switch head. I found this to be the most challenging drawing to create as there are many small features to dimension. When dimensioning this, I had to make sure each arch, angle, and fillet was accounted for. As you can see from the three views, you're able to get most of the detail of the switch. And finally, the section view shows how the model is shelled. This likely is because it allows for easier injection molding, in addition to less plastic and a lighter part. Overall, my drawing does not contain any overlaps, and getting it to be fully dimensioned was a challenge, accounting for every single part. In addition to being the hardest drawing, it was certainly the hardest part to model. The switch is pretty small at less than an inch tall, so getting the digital calipers into the tight crevices to measure all features accurately, especially the ones in the center, was pretty challenging. In addition to it being small, it also had small features that were hard to model, including a few knobs and some of the internal components where my calipers couldn't reach. Also, as you can see, there's many weird angles, and there's no reference for those angles, so it was challenging to get them accurate. While modeling this, I had several times where SolidWorks crashed on me, and I would have 15, I think at the worst case, 30 minutes of unsaved work. Throughout the project, I learned the importance of saving the files as often as possible, partially because my auto recovery never worked, partially because the model, especially the assembly, was just too large and too much memory. In addition, I learned how to get like high quality measurements using each feature of the digital calipers to measure internal parts, external parts, figuring out the screw pitch, all of those, or using the depth feature of the digital caliper. All of those were very important for my model. The tolerances were tight, so using the right tool made a large difference in how the assembly lined up. The assembly for this light switch was pretty complicated, so I had to be smart with my mates, making sure I had lined up the parts on the right face or mate such that all parts could fit together. A lot of the parts were sheet metal, which was something that we haven't covered in this course very much. So I had to gain the new skills to create these sheet metals with some complicated features to them. As one of my professors says, every model is a bad model, and unfortunately, with this project, some of it shines through. Overall, I was happy with the way things turned out and the accuracy. However, as highlighted in this photo, using SolidWorks and physics was something that this scope of the course does not cover. So where the metal bends to either allow electricity to flow or not flow, I was not able to model this properly. The way I overcame this was to dimension the parts to be in their default state where I could like not represent the physics. However, as seen in the photo above, the model does have overlapping, which I'm unable to fix. Otherwise, apart from missing threads, this model is very well done and similar to the real world device. I really enjoyed this project and learned a lot from it, and I'm happy with my final results. I hope to learn more about SolidWorks and improve the physics of my model. Thank you for your time.